Hey guys, I'm going to talk a little bit about molding, what's involved in molding, when you would use it, why you would use it, why it's better. Um, so when you do print to raw cast, I have a couple of things on my account here, and we'll go through it properly. First of all, this is not the official video. A proper video will come out later. Now, I'm doing this under a microscope, so it's clear to everybody what we're working with. I'm also going to be honest and say that I picked the worst case scenario model here. This model, there's no angle that's not skew. Everything on this leans in every kind of angle. This is an awkward thing to work with. It is especially awkward for printers to work with because of all the angles. It gets this striping on it, which is not grow lines, it's actually moire lines. It's struggling to get these angles across the pixels available to the printer. Anyhow, that don't need all that technical nonsense. Suffice it to say, this is a nightmare thing to print and cast and to get it clean, right? You can see all that hectic striping happening over there. Let's pull it up closer for you. Now, every time I say the word awkward in the next few sentences, think 15 minutes, all right? Think jeweler time. Somebody has to awkwardly try get in here with a thrumming string to thrum and clean this area and then hopefully not chew a big gouge in there, right? Somebody has to get in there with a thrum. Somebody has to get through here with a paper disc. Somebody has to get in the bottom here with a very small file. Somebody has to get in there with thrumming in there, thrumming through the bottom here, buffing, cleaning. All right, so this thing, I would estimate that and its shank mate, I would say is a 2-hour clean to a 2.5-hour clean if it isn't platinum. If it's platinum, add another 45 minutes or an hour, let's say 3 hours, right? Platinum with the yellow shank. If you only ever made this one, maybe that's cost effective. I don't know. But if you had a way that you could make this clean up in half an hour and you did 10 of them, there's 2.5 hours times 10. At 8 hours a day, there's 3 days of labor you saved on the first 10 that you made. All right, so there's a labor math, which is the more expensive component. The second part is the awkwardness of how it has to be produced. So 3D printers need supports. They need areas to hold the components. So you've got all this kind of nonsense going on. You can see where all the little pips are from supporting. That was required because this had to print in this direction. 3D printers have to be self-supporting. And then to get the metal to the cast from the 3D print, we've had to run through the prongs. So we make a little mark where the jewelers have to cut it off. But we don't cut this all the way back. So quite often we probably clip that over there. But on this part, if you order 10 of them, let's say there's half a gram here. After 10 of them, you paid for 5 grams of material. And depending on the material, there's already a big cost. All right, so it punished you for labor and it punished you for material, and it's an awkward clean. So let's talk the last component, wax. Wax has been around, wax casting been around 6,000 years. Lost wax, and it's called lost wax because it's wax and everything wants to be wax. The problem with these things is they are not wax, they are resin. They are prone to issues, they are slow to build, they take overnight to build, overnight to burn out, and on day 3 they cast. And they are quite prone to problems. Resin leaves ash inside of a casting flask, and that ash can cause surface defects and cause miscast. So sometimes it can be 3 days, sometimes 4 days, sometimes 5 days before you get a component. All right, the more awkward the component, the more likely the failure. All right, so there is cost of time. Anything in wax never fails, and always, if I put on a tree tonight, it's off the tree tomorrow morning. There's a 24-hour turnaround on it if the order got in time, right? This is, we're now talking about 72 to 90 hours turnaround. Okay, so that aside, let's have a look at the difference. So what happens with these things and the cost of a mold? People think, oh, you just made a mold of a thing. We didn't make a mold of a thing. The mold we made had to first be printed. So we did that work. We did a 3D print. We produced this casting. We clipped this casting back. We polished the components, and we made a master. So in the cost of the molding is the cost of master modeling. So we produced the master model in silver. You can see over here it's a little tarnished because it's been out of the rubber already. We did the work, we did the thrumming, we got in there, we cleaned away all that material, we cleaned up everywhere so that we can make a rubber mold and retain that surface. Okay, and the same thing for this guy's shank. So, and that has to be adequately scaled, all right, because there is a little bit of shrinkage. So all that mathematics we did, the molds we produced, and then we produced a rubber mold. It's not just making a rubber mold. There's the thing that went into the rubber mold. It's also produced. Okay, that's actually the most expensive part. Making rubber mold is the cheapest component. All right, but once a rubber mold exists, it then allows you to do this. All right, I can inject about, I think, 90 an hour of this. All right, so I can have, if you placed an order at 10 a.m. in the morning and had the mold handy, I could probably put 90 of those on a tree within the same day. All right, and then in the next day, you'd get this cast versus this cast. So here's your metal saving of all the nonsense that was on the top. You have a better surface finish. So the jewelers would know over here a heavy wax and a rouge will most likely get you 90% of the way here. You're still going to have to go in with goat hair a little bit on the side and underneath to give it a bit of a buff. But compared to having to deal with the striping and these lines, this is a way faster job. Way faster job. All right. And then the last component, I guess, is smart business to sell what you have, right? Not sell what you don't have. So if you knew that, for example, these crossover sweeps were popular and you did a mold in a 50, 25, 25 point, 75, 40, 40, carat, 50, 50, carat and a half, 60, 60, something like that, and you produce the mold, like these would probably, you could fit 3 or 4 of them in a single mold, right? And you injected them and you kept them in your popular alloys and you did a couple of shanks. So you did an upsweep shank or you did a shank with a bevel edge or whatever it is, all right? There is a little bit of inventory cost in there, but think about the mathematics on the sale. So your salesperson goes out and the customer's going, oh, 3 stones, I want this thing that's got Tinkerbell on it and 2 people hanging off the side. And you go, oh, that's great, but have you thought about this? Right, a salesperson sells what you have. Now, I've worked in a company where the salespeople did that. And by 10 o'clock, they sold what we have. I can go into the library of components. I fetch the components we already have. And by 3 o'clock that afternoon, I've already set the stones. Within the same day, the customer walked in the morning and that afternoon had a ring on their finger and there was 50 grand in the till without problems and without a single email. That's the biggest advantage to molding. Build a library of components that you know you can sell. It's not going to be all your sales. You're always going to have custom. But if it's 30% of your sales and 30% of your sales is instant gratification, your customers love that, especially younger customers. I could just walk in and I got it. It was there and I had it the same day. Don't undersell what that's worth. All right, picking the most difficult and complicated way that also has a pretty average output is maybe not the way to do this all the time. So then we did do a mold to finish sample and a print to finish sample, but I can't find there we go. I can find the print to finish sample. So we gave these as a blind test to our jewelers. I haven't even seen it myself. This is print to finish with the jewelers. They did a pretty good job, but you can see they kind of missed a few areas. Then this is mold to finish. Better. But it's more shiny in more areas because there was more hard work done on this prior to casting. Because our jewelers are really good, I don't think you could tell a huge difference between the two, but I can tell you that this one took 17 minutes to clean up and this one took 48 minutes to clean up to get to the same level, and this one I think looks better, right? So it's not a huge difference between it, but we have the same jewelers who did this worked on a bunch of them, so they had a bit of experience going through it. You with me? I'd like you to consider what that means as a business. I'd also like you to consider that when we say we're charging you for a mold, there is an insane amount of labor that went into it before we even got to the mold. All of this had to be produced. It had to be CAD drawn. The CAD had to be signed off, specifications. We had to do the prints, do the cast, do the scaling, do the cleanups. And then, yes, a little silicon mold was made. That's worth $50. That's not the cost of making a mold. The expensive cost of making a mold is getting to this point, to the master model. And that's what we produce really, really, really well. And that's the highest impact of molding cost, because this thing has to be valid for the next 10,000 pumps. Okay, so this will become an official video later on, probably a little less colorful than my video, and it will be in our marketing media. Cheers, guys. Bye.